ways. Wait a minute. This is not a trick question. Somebody tell me the answer to that. Okay. Now, to be fair, sometimes when I ask questions that easy, you think I'm tricking you, and all 30 of you sit there like this. Oh, look at you. That's not what we're doing, but nice. I didn't even think of that. Okay. You can all add, right? Okay. What's this? 2x. Well done. It is not x squared because I'm not multiplying. Okay. So now all of you can do this. 8x. Lovely. Now, what about this? What's that? 5x plus 3y. Why does this one not change, but the green one did change? Because they have different variables, right? This, there are 5 x's, not multiplied, there's 5 of them, and 3 y's. You don't know how much this x is worth, and you don't know how much this y is worth, so you cannot tell me this answer. But over here, no matter what you say, x and x are the same. If you make x 7, this is 35 plus 21, which is 56, which is, of course, 8 sevens. Everybody understands why like terms work, correct? Everybody can do it, yeah? All right. Now, this construction or expression, x, y, means x times y. So if I have 5y, that means 5 times y, right? What do we call that? Don't say 5. That's a coefficient. Excellent. It's a variable, but it doesn't have to be a variable. What we call the thing that the coefficient multiplies is an argument. Now, if I have arguments that are the same, then I can add or subtract. And we already know this from the 9th grade when we learned about like terms, right? So, if we know what to do with 5y, because that's a coefficient, and that's an argument because the coefficient multiplies it, then don't we already know what to do with that? Because isn't that a coefficient and isn't that an argument? Because it is a number times something else. Does everybody follow this logic? It's easy, right? So, if we can put together x's, what should we be able to do with that, and that? Why? Because they all have the same argument. This is exactly the same as 5x minus 3x minus 4x plus or y. Everybody understand? So already you know how to do the first question. What is the answer going to be? Easy peasy, lemon squeezy, do this in your sleep, right? Right? Okay. I've said it before, I'll say it again, I will say it again and again and again and again. Can you forget any other math? Can you forget the math Mrs. Bad Crumble taught you in grade 3 when you were in pre-calc 11? No. Can you forget the math Mr. Myers taught you Thursday on Monday? No. So, since we need to know every bit of math that we have, they're all available at our disposal, yes? So right now, can I do anything with that? Yes or no? I can, but is it the operation that I'm being asked to do? I can't do that yet. But always in my math abilities, I have the chance to make things look differently so they can work together, right? If I gave you this, 1/7 plus 3/4, you can't add that right now, can you? You have to do something to it so we can add it, right? Well, I can't do anything with this right now, but maybe I can do something with it so that I can. What would I do if the only thing on the page was that root 32? What would you do? You'd simplify it, right? Because that is 16 times 2, right? And what would you do with that 16? It would be 4 root 2, yeah? Okay. Now, the 32's gone. What am I doing with that? That's 4 times 2. What's coming out? Plus 2 root 2. Now, what is my answer? 6 root 2. Because it's exactly the same thing as 4m plus 2m, which would get me 6m. Does everyone understand? That's it. That's how you add and subtract radicals. You do this one and this one. Go. Maybe you need a little bit of a nudge to get started. 4 and 7. Soon as you see that, which of those is the one that's coming out? The 4. So logically, since I want you to simplify, wouldn't 7 be a good one to try there? And it works, 9 and 7. Logically, what should we try there? 7. And that ends up being 16. And now it's easy. Finish that one. Then do D all by yourself. Who wants to tell me what to do with 20? Because by now you should have checked C and you should have been okay. What should I do with 20? To what? 4 and 5. 2 root 5. Minus. What should I do with 45? To what? 9 and 5. Where does that 9, what happens to it? So it's minus what? And what is 2 minus 9? Root 5. Is everybody good? Everybody can do this, right? Because there's nothing new. We're taking what we know, 5x plus 5x, simplify radicals, and putting it together in one exercise, right? It's how we learn how to do everything, isn't it? Can I slide to the next page? Excellent. So, let's do the first one together. 98. Maybe you're in trouble. You don't know what to do there. You got to break it down the long way. First breakdown is probably going to be 249. Why wouldn't it be? It ends in 8. Why can I stop there? 49 is a perfect square. So what's coming out, Ashton? 7 root 2. What about 20? 4 and 5. We just did it. What's coming out? 2 root 5. And 18? 9 and 2. What's coming out? 3, leaving a root 2. Some of you are going to stop there. Is that right? Why not? I got a couple of arguments there. Just because they're not right beside each other, does that mean I can forget about them? Of course not. So I got 7 root 2s and I'm adding 3 root 2s. How many root 2s is that? 10 root 2s minus 2 root 5. And there I have to stop. Why? Because that's the same as 10x minus 2y. And I'd be done. Right? Do B. Go. Numbers get a little bigger. Doesn't change how we do it. I'll wait a moment for everybody to finish with B. Don't start C because there's a couple of things I want to talk about on C. Most people should be pretty close to done, but of course if you're not, it's no big deal. There's no rush. And is everybody cool? Everyone's good? Everyone's good, yeah? Okay. 2 things are going to happen in C that I wish to discuss. But the first thing we're going to do is, of course, tidy it up. What's different? What's different? They're roots. We're looking for cube roots now, but do our methods change? Of course not. So I'm going to look for cubes here. So that is 27 times 4. I've done this so many times that I know 27 works with 108. So what's the cube root of 27? 3, so what's coming out here? 3, so I get 9 cube root 4. Now right there I want to stop for a second, because some of you, as soon as you see this, notice I didn't highlight the 3, some of you are going to tell me that answer is 2. It isn't, is it? because 4 has no cube root. 4 only has a square root. So you must be careful when you're simplifying these. All right? Make sure you recognize what it is you are looking at. That's the first thing I wanted to mention. Now we'll just carry on. This is 8 times 4, right? Why would I use 8? Because 8 has a cube root. So what's coming out? 2. So minus 4 cube root 4. And this one, it's a big number, right? How many people have to go to a factor tree? Probably most of you. But you got a hint here. 4, 4. What should we try here? Let's go for 4, which gives us 64. And I can stop there, can't I? Because 64 is a perfect cube. What is it? 4. So what's coming out? 4. 4 times 3 is 12 cube root 4. So that gets me 9 minus 4 is plus 12 cube root 4. Now, I already talked about this. Some of you are going to make a mistake. Tell me that's 34. Because you're going to say the cube root of 4 is 2. Because you're used to seeing that, right? That's problem 1. Problem 2, and I haven't shown you this. So I want to know what you think. Can I do this? 3 cube root 6 plus 4 square root 6. Do you think I can do that? What do you think? Could I give it in a weird decimal? If I have my calculator going. But could I make this 7 something root 6? Can I combine it? No. Everybody cool? All right. Good. Now, how many of you look at D and right now are a little, ugh? Be honest. D looks freaky deaky, doesn't it? Because it's a mess. Of course it's solvable. Because I would never give you something you couldn't do. But it looks scary right now, right? What's the number one instruction I've been giving some of you since the 10th grade? Starts with an S, ends with a Y, has implif in the middle of it. So let's simplify. Where is there something I can simplify in yellow right now? I could simplify that cube root 48. I could do that in my sleep, right? Isn't that 8 times 6? And isn't the cubed root of 8 2? So isn't that 18 cube root 48 over 2? Isn't it?
Shouldn't you do something with that 48?
Oh, sorry, not 48. Thank you. It's 6. Isn't it?
Yeah.
Now, 18 over 2. What's that? 9. 9 cube root 6. Oh, that's a lot prettier than that, isn't it? Okay. Let's look at this one. What can I simplify in there?
The
Cube root of 162. Right? I can break that down. Isn't that 81 times 2? And isn't that 9 times 9? And isn't that 3 squared times 3 squared? How many 3's you got there?
4.
What's my group? What's the group I need? 3. I got 4 of them. So can I bring out a 3? I can bring out a 3. So now I got 3 quarters times 3, which is 9 quarters, isn't it? What did I leave under there? I left that 2 and one of those 3's. Cube root 6. Hey. What can I do there? Isn't that 125 times 6? What's the cube root of 125? 5. So what's coming out? What's already there? So isn't that 3 root 15? 15 cube root 6 over 5. And what do I see right there? 3. 3 cube root 6. Now, there's still something there that's bugging us. There's a lot less there, isn't there? What is 9 minus 3? 6 cube root 6, right? Now, plus 9 fourths cube root 6. Well, isn't 9 fourths just 2 and 1/4? And what's 6 plus 2? 8 and 1/4. Cube root what? 6. All done in our heads without a calculator. That is scary. But as soon as you apply the knowledge that you already know to the easy parts of it, what happened? It got a lot simpler. Now, do you have to do what I did here? Of course not. Some of you may say, oh no, Mr. Myers, I don't dig that. I see 9 quarters here. I don't see 2 and 1/4. Oh, okay. Well, this was 6, wasn't it? Well, if I want to add 6 and 9 over 4, that's 6 over 1, isn't it? Which would be 24 over 4, wouldn't it? What's 24 and 9? 33 over 4, right? How many 4s go into 33? 8. How many fourths are left over? 1. Everything on the screen right now is something you all already know how to do, right? Putting it all together, we haven't done that before. But that's always how we learn stuff, isn't it? You put together what you know. Never will I ever give you a question that you don't have all the tools to solve. But I've made the analogy before. Don't look at the end of the journey. Look at the beginning. Do something mathematical that you know how to do and see if that leads you somewhere else. Everybody with me? All right. Now, let's talk about, we're going to do page 39 together, and then I'm shutting up. So, triangle has these side lengths. Blue, yellow, green. How do I find the perimeter? I add it up. So, well, I know how to add. 5 root 28 plus 3 root 252 plus 5 root 112. I can't add those, so I do what I know. What do I know to do right now? Simplify, break down those radicals. So what's 48? What's 28 going to break down into? To get me what? 10 root 7. What's 252 going to break down into? 36 and 7. So what's coming out? 6. To get what? 18 root 7. Now, you're smart kids. 7 is worked 2 times. What would be a logical thing to try here? 7. And that gets me, I should have changed colors. That gets me 7 and 16. So what's coming out? 16? 4. And what's already out there? So what do I got? Plus 20 root 7. Now what do I got? 48 root 7. Everybody cool? Now, I'm going to do something weird here. I'm specifically, not pacifically, specifically asking you to tell me it as an entire radical. Why would I ever really want you to do that? Would you ever, in the work of a question, can you envision a time where you would take something that's nice and easy and make it complicated? Why would I ask you to do this? Is this B here a math teacher question that has a goal, or is it a math student question that you would want to do? It's the first one, right? I want to show you something. If there's a 48 out here, what was under there? 2 48s. So this would have been the square root of 48 squared times 7, which is a crazy big number. What is it? Somebody with your calculator, because I can't remember exactly what it is. It's like 16,000 or some crap.
Yeah, 16,128.
The reason I want you to do this is to show you this. These are the same thing. Which one is easier to work with? This one, right? Always, 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 always simplify. I cannot stress it enough. If you see anything that you can make easier, don't worry what the question is asking you. Don't worry about where you got to go. Don't worry that it's 37 steps and you don't really remember the 35th. Because the first thing is to make it something you can work with. Everybody understand? Okay. So now the next thing, this is a real thing. What is the half perimeter? What must I do to the perimeter to find the half perimeter? I must divide by 2. What is my perimeter? Would I use the blue or the yellow? Of course I would use the blue one. 48 root 7 over 2. And get what? What's the answer? Remember, this is the same as 48x over 2. 24 root 7. That equals my semi-perimeter, or S. Now, we already had this formula once. Almost all of you ignored the question because it looked scary. Is there any need for it to look scary here? No, because square root of what's S? 24 root 7. And in the first brackets, S minus A. 24 root 7 minus what? 10 root 7. What's S minus B? Minus 18 root 7. Agreed? And what is S minus C? Agreed? Now, pretend you're a regular kid on the street not taking pre-calc 11. You're a kid in grade 10, and someone walks up to you with that. Does that look scary? Damn right it does. But is it? What do I do with the green part? Times 14 root 7. What do I do with, oops, the part I just crossed out in black that was supposed to be highlighted? What do I do? He waited patiently. 6 root 7. And what do I do with the part that is orange? 4 root 7. Is it still scary? Looking less. What do you know about 24, 14, 6, and 4? They're all the numbers, aren't they? 24, 14, 6, 4. And what do you see there, and there? Isn't that root 7 to the what? Fourth. If there was nothing but 24 there, what would you do? If 24 was the only thing under that radical sign, what would you do? If you just had this, what would you do? You'd break it down, right? What would be your first step? 4 times 6, correct? Right? Because 4 is a square root, right? What do you see now? Is that a pair of 4s? What am I looking for here? What am I looking for? Pairs. How do I know I'm looking for pairs? Because it's a square root. What do I see there and there? They're the same. Is that a pair? So what is coming out to the front? 4 and 6, which is going to give me 24, correct? What stayed under there? No, we got rid of the 24. Just 14 stayed under there, right? Because we took out the 4s, we took out the 6s. Everybody cool? Now I got to look over here. Hey, wait a minute. If this was x to the 4th, what would come out? X squared, right? But it's not x to the 4th, it's root 7 to the 4th. So what's coming out? Root 7 squared. What is root 7 squared? 7. 24 times 7, root 14. What is 24 times 7? Mr. Myers, I can't do that in my head. Sure you can. What's 20 times 7? 140. What's 7 times 4? What's 140 plus 28? 168 root 14. And did you do any grade 11 stuff there? Technically, everything we did there you learned last year, right? Because you learned simplifying radicals last year, and you learned how to add coefficients and arguments in grade 8? Maybe grade 9? So, that don't waste my time, right? But isn't just the same as that? So is there any need to be stressed? And yet you're all still stressed. But you know how to get there. How do you get there? One step at a time, right? And have you been given every single step? More than once? So, what's the only way to get somewhere? Try to go there. Your job today is page 40. Now listen to me carefully. It came as a big shock to somebody in this class whose name I will not mention, but it may be somebody who is slightly geographically challenged, that we have a test tomorrow. It's been written on the board since last week. You are writing a test tomorrow on exponents. What part of exponents? All parts of exponents. Do you have a page reminding you of what specifically this class has done a little bit poorly at? Yes. Do you have a page specifically that I told you in the book to look at? And if you can do that, you would be A-okay. So, if you haven't looked at those pages yet, what should you do tonight? Look at those pages. Should you be concerned about page 40? No, because the next time we will guaranteed talk about page 40 is when? Wednesday. What if you finish your test a little early tomorrow? What would be a good use of the quiet time in the room when everybody else is still writing their test? Page 40. What if you get page 40 done right now? Then what do you get tomorrow when you finish writing your test? Time to contemplate the meaning of life. All right? Which, of course, as you should have figured out by now, comes down to math. Okay? Okay. Ready, steady.